Okay, so like imagine trying to teach a super smart AI to solve like these crazy hard problems for you, right? But this AI, it's like a total drama queen. Sometimes it takes forever to give you an answer, like it's overthinking everything, and then other times it jumps to conclusions before you've even like finished explaining the problem. Wouldn't it be amazing if we could teach AI to just chill out a bit,
Hmm.
like know when to put in the extra effort and when to just go with the flow?
Yeah, definitely.
Well, that's exactly what we're diving into today, making those large language models, or LLMs, way better at reasoning. And our guide for this deep dive is a research paper called Efficiently Serving LLM Reasoning Programs with Certain Dicks.
Ooh.
But before we get lost in all the technical jargon, can you break it down for us? Like, what exactly are these LLM reasoning programs, and how are they different from, say, the LLMs we chat with through our favorite apps?
So, that's a great question. And the difference is actually pretty huge. Think of it like this. The chatbots you mentioned, they're like a sword and army knife. They can do a lot of things, okay?
Yeah,
But they're not always the best tool for the job.
right.
Reasoning programs, though, are like specialized tools.
Mm.
Each one is designed to be awesome at a specific type of reasoning task.
Okay, I get it.
Yeah. And this research paper focuses on four main types.
Okay.
So one is called self-consistency, or SC for short. Kind of like crowdsourcing for answers. You get a bunch of different opinions from the LLM, and then you go with the most popular one.
So it's like the AI is taking a vote.
Exactly.
That's pretty clever.
Then there's rebase, which is all about strategically exploring possibilities.
Yeah.
It's like building a tree of potential solutions and then ranking them. And then you focus on like the most promising branches.
Ooh, I love that analogy. So it's not just random guessing, it's about making smart choices about where to look next.
Exactly. You got it.
Okay, cool.
Then we have the third type called Monte Carlo tree search, or MCPS.
Hmm.
It also uses this tree structure, but it's even more strategic. It's like a grandmaster chess player,
Mm.
analyzing all the possible moves and then spending more time on the ones that seem like they'll lead to victory.
So MCTS is like the LLM's inner chess champion. I'm
Yeah.
starting to see how these specialized programs can really up the AI's reasoning game.
Absolutely. And then the fourth type is internalized chain of thought, or ICOT.
Okay.
And this one is super fascinating because it kind of shows how the latest LLMs like GPT-4 are evolving.
Hmm.
They can actually do this internal reflection without needing all these extra algorithms.
Wow, so the LLMs are becoming more self-aware in a way.
Yeah, you could say that.
That's kind of mind-blowing. But here's something that really jumped out at me in the paper. All these reasoning programs have this like thinking knob that controls how much effort they put in. But how do we know where to set that knob? Like, how do we find that sweet spot between too little thinking and way too much?
Right. That's where it gets interesting. It's this balance between compute power and accuracy. They call this inference time scaling in the paper.
Okay.
It's like if you're trying to translate a simple phrase, you don't need some massive supercomputer.
Right.
But if you're translating like a super complex legal document, you need a lot more firepower.
Yeah, it's like choosing the right tool for the job. You wouldn't use a sledgehammer to crack a walnut.
Exactly.
Yeah.
You can picture it like this scaling curve. There's an easy zone where simple problems are solved really quickly, and then there's this scaling zone where more compute power actually makes a big difference. And then finally, there's the impossible zone where the LLM just can't figure it out, no matter how much compute power you use.
Okay, that makes sense.
Yeah.
But here's the thing. In the real world, we usually don't know how hard a problem is before we try to solve it. It's like being handed a puzzle box and having no idea how many pieces are inside. So how do we adjust this thinking knob as we go? Do we just keep cranking it up until something happens?
Good question. That's where this thing called certain decks comes in.
Right.
It's basically a way for the LLM to tell us how confident it is about its answer at any given moment.
Yep.
It's like the LLM's internal gut feeling meter. The higher the certain decks, the more confident it is.
So it's like the LLM is saying, hey, I'm pretty sure I've got this, or, oh, I'm not so sure about this one.
Yeah, exactly. And the cool thing is that different reasoning programs have different ways of calculating certain decks.
Oh, interesting.
For example, SC uses something called semantic entropy, which basically measures how much variation there is in the LLM's different opinions.
Okay.
While MCTS and Rebase use scores from a reward model that tells them how good their current solution seems.
So it's like each program has its own way of gauging confidence, but CertainDex gives us this common language to understand what they're feeling. That's brilliant. But let's get practical here. How does all of this help me, the user, get better answers from my AI assistant? What's the takeaway here?
Good question. So think of certain decks as your AI assistant's way of saying, hold on, I'm almost there, or this one's got me stumped. By paying attention to certain decks, we can do some really cool things.
Like what?
Well, for starters, we could be way more efficient with resources. We can give tougher problems more compute power and let the easy ones slide by without overthinking.
So no more watching the little spinning wheel of doom while my AI assistant is off on a mental tangent.
Haha, exactly. Certain decks also allows for early termination. So if the LLM's clearly stuck in that impossible zone we talked about, certain decks can tell us to cut our losses and move on.
Gotcha.
And by being smarter about how we use compute power, we can actually solve more problems correctly. It's like giving your AI a turbo boost.
Now that's something I could get behind. Speaking of which, the paper introduces this system called Dynasor that uses certain decks to optimize these LLM reasoning programs. Can you give us a quick rundown of how this Dynasor thing actually works? It sounds pretty complex.
Yeah, it is. But basically, Dynasor is like the conductor, making sure all these different reasoning programs and their certain X levels are working together smoothly. It has four main parts. First, there's the reasoning program abstraction, which is like a standardized interface for developers to plug in their different reasoning algorithms.
So it's like a universal adapter for all these specialized AI tools.
Exactly. Then there's the application runtime, which is constantly checking certain decks and adjusting those thinking knobs accordingly.
Okay.
It decides which programs get more resources and which ones need to be held back.
So it's like Dynasor is constantly assessing the situation and making sure everything is running smoothly.
You got it. And then there's the system runtime, which is responsible for actually executing the requests on the hardware. It's the engine that makes it all go to the CANA. And finally, there's the profiler, which is like Dynasor's personal trainer.
Haha, okay.
It helps calibrate the system for specific tasks and data sets, making sure everything's performing at its best.
So we've got our central hub, our project manager, our engine, and our personal trainer. It sounds like a well-oiled machine.
Yeah.
But does this actually work in practice? Did the researchers find that Dynasor actually delivers?
Oh, yeah. The results are really something. In batch processing, when you have a bunch of tasks to handle all at once, Dynasor saved like a whopping 50% of compute power compared to the standard methods. And get this, it did all of that without sacrificing accuracy.
Whoa, 50%. That's insane. It's like getting twice the work done for the same amount of effort. I'm guessing that translates to some serious cost savings, too.
You bet. Especially when you're dealing with these massive language models, which, as you know, can be really expensive to run. But it's not just about saving money. Dynasor also showed huge improvements in online serving, where you need to be able to handle a constant stream of requests.
So it's not just efficient in a vacuum, it actually makes these AI systems more responsive in the real world. That's super impressive.
Exactly. Dynasor handled 3.3 times more queries every second and met tighter deadlines. So that means faster responses for you, the user, without skimping on the quality of the results.
Now that's what I'm talking about. No more waiting around forever while the AI is thinking things over. I did notice, though, that the paper also talks about finding the right certain deck's threshold. It seems like that would be pretty important for getting good results right.
You're absolutely right. Calibration is super important. Different tasks and data sets might need different thresholds. But luckily, Dynasor has that built-in profiler we talked about earlier to help us find the sweet spot.
Right.
It's all about finding the right balance between being careful and being decisive.
So it's like fine-tuning the AI's instincts. Knowing when to trust its gut and when to maybe double-check its work. Makes sense.
Exactly. And the cool thing is, the profiler takes care of the hard work for you. It looks at the specific task and data you're working with and figures out the best certain deck's threshold. So you can just sit back, relax, and let Dynasor work its magic.
Okay, so Dynasor is like a personal AI trainer helping those LLMs reach their full potential. But I have to ask, does using certain decks actually make these LLMs smarter? Or is it just making them faster and more efficient?
That's a great question. And it gets to the heart of what makes certain decks so fascinating. It's not just about speed and efficiency. It's also about enabling a deeper level of reasoning.
Okay, I'm intrigued. How do certain decks lead to better reasoning, then?
So think about it this way. We humans are good at knowing when we need to think harder about something, right? If a problem is easy, we just breeze through it. But if it's challenging, we slow down. Think about it from different angles and maybe even ask for help. Certain decks lets LLMs do something similar.
So instead of just blindly crunching numbers, they can actually adjust their approach based on how confident they feel. That's pretty amazing.
Exactly. And by being smart about how they use compute power, they can explore more complex lines of reasoning that they might have missed otherwise. It's like giving them the mental flexibility to handle tougher problems.
This is starting to sound very human-like. Is it possible that certain decks could even help LLMs learn from their mistakes? Like we do. I mean, we learn best when we can recognize our errors and adjust accordingly.
That's a fascinating thought. And it's definitely something researchers are looking into. Imagine an LLM that can not only recognize when it's uncertain, but also figure out why it's uncertain, and then use that information to improve its reasoning process or even look for more data to fill in the gaps in its knowledge.
That would be a total game changer. It would mean AI that can actually learn and grow on its own.
It's a very exciting possibility. And certain edX could be a key part of making that happen. By giving LLMs a better understanding of their own limitations, we open up all sorts of amazing opportunities for improvement.
This is really mind-blowing. It's crazy how a simple concept like CertainDex can have such huge implications for the future of AI. But let's bring it back down to earth for a minute. What are some of the more immediate practical uses of this technology?
Well, the paper focuses on improving the efficiency of LLM reasoning programs, which has big implications for tons of different applications.
Like what?
Well, for example, imagine you're using an AI-powered coding assistant. With CertainDex, that assistant could become much faster and more reliable at generating code while also using less compute power.
That would be awesome for developers.
Mm.
No more waiting around for the AI to catch up.
Exactly.
Yeah.
And it goes beyond coding. Think about AI-powered research assistants that can go through mountains of scientific papers, pick out the important stuff, and even suggest new research directions. Or AI-driven legal assistants that can analyze complicated legal documents and give expert advice.
It sounds like CertainDex could change the way we work and learn. It's like having a super-powered brain at our fingertips.
It definitely has the potential to be super transformative. But it's important to remember that CertainX is still a fairly new concept. There's still a lot more research to be done to fully understand what it can do and what its limitations are.
That's a good point. We need to be careful about getting too hyped up. But it's hard not to be excited about the possibilities. So where do we go from here? What are the next steps in developing CertainDex?
Well, one of the most exciting directions is looking at how CertainDex can be used to make LLM reasoning more transparent and explainable. Right now, these models are often seen as black boxes. We know they can produce incredible results, but we don't always understand how they get there.
Yeah, that's a big problem for building trust in AI. If we don't know how these models are thinking, it's hard to fully embrace their recommendations. Yeah, it's like we're handing over control to these super powerful AI systems, but we don't really know where they're taking us.
Exactly. And that's where CertainDex could really make a difference. By giving us a peek into the LLM's thought process, we can start to understand how it's making decisions and maybe spot potential problems where it might need some help or guidance.
So it's like having a dashboard that shows us the AI's inner workings. That would be incredibly helpful, not just for developers, but for anyone who's using these systems.
Right? Imagine being able to see the actual steps the AI took to reach a conclusion. You could then look at the reasoning process, see if there are any biases or mistakes, and then make a better decision about whether to trust what the AI is telling you.
That would be a game changer. It would make AI so much more transparent and accountable, which is super important if we want people to actually use and trust these technologies.
Absolutely. It would also open up some really cool new applications. Imagine using CertainDex to create AI tutors. They can not only give you the right answers, but also explain how they got there in a way that students can actually understand.
Whoa, that would be incredible. It would be like having a personalized teacher who can adapt to each student's learning style and pace.
Exactly.
Oh.
And it goes way beyond education. Certain dexes could revolutionize fields like medicine law and finance, where being able to explain AI's decisions is absolutely critical.
I'm starting to see how certain decks could be the missing piece to unlocking the full potential of AI. It's not just about making these systems smarter, it's about making them more understandable, more trustworthy, and ultimately more beneficial for everyone.
Couldn't have said it better myself. It's like we're entering this whole new era of AI where things like collaboration and transparency are just as important as raw processing power.
This has been an amazing deep dive. We've gone from the technical details of certain decks all the way to its potential impact on society. It's clear that this technology has the power to really change the world.
Yeah, it's a reminder that we're living in this crazy time of incredible technological advancements. And it's up to all of us to make sure those advancements are used for good.
Well said. So we've come to the end of our exploration into the world of certain decks. I hope you've enjoyed it and maybe learned a thing or two along the way.
And if this deep dive has sparked your curiosity, go out there and explore. There's a whole world of knowledge out there waiting to be discovered.
Thanks for joining us on the deep dive. Until next time, keep exploring, keep questioning, and keep learning.